right, 8.1.1, how can I find the product? This is an introduction into factoring quadratic expressions. We've learned how to multiply algebraic expressions using algebra tiles as well as generic rectangles. And in this section, we will focus on reversing this process. So how can you find a product when given a sum? So what we've done before is we've been given two things in parentheses. Two factors in parentheses, and we had to get it to equal something that was not in parentheses, and we've been using the area model for that, which is where we take a rectangle and we go base times height, and we put the two factors on either side, top and bottom, or side and top, however it is you want to say it, and then we have been multiplying. And what comes out of that? That is the area. And that will go in there. And that is the area model that we've been doing. So we have our base here. And then we have our height here. Okay, that's our height. All right, and then so what we would end up doing, what we're doing is we're going to be working this thing backwards, and that's called factoring. So factoring is we are taking it apart. We're going to take it apart. So we were going this way. We would have these, and we would go and we get this. Now we're going to be given the product, and we're going to have to find these. And so we're going to be doing it backwards. And so let's get into it. So here we are going to review some products and sums. So what we're going to do, we're going to write the area of the given rectangle as a product and as a sum. Remember that the product represents the area found by multiplying the length by the width or the base by the height. And while the sum is the result of adding the areas inside the rectangle. So if we look at these first, let's look and try to figure out what exactly do we have inside this rectangle. So here we have an x and a y. So we got an x and a y here. That's an xy. And then what we end up with is we then got a y. So these are all y tiles. And then we also have this x tile here. So these two are x tiles. And then we have an x square. That's an x squared tile there. And it takes an x with an x to make an x squared tile. So these are all x's here. And then what's left over is we have some 1's. So that's what we have. And if we were to look at this and try to figure out what we have inside, ultimately, we take these and we just add them up. So if we kind of look at this, it kind of helps with a little bit of organization. But apparently we've got an xy. We do have an xy, which we've got one of those. So we've got one xy tile. Then we've got 4 y tiles. So we have 4 of the y's. We have 4 y tiles. And then we've got 1, 2, 3, 4, 5, 6 of the x tiles. We've got 6 x tiles. And then we've got 2, 4, 6, 8 of the 1's. And then we've got 8 of the 1's. And now we've just grouped these into piles. And so now we just have to, and we also have an x squared. Almost forgot the x squared. Okay, don't want to do that. So this is what we have. So all we have to do now is to figure out what we have inside here. We put them all together, we stack them all, we group the like terms. Okay, and so another way to group them could be to simply start putting some lines in here that could represent boundaries and borders or partitions, and help us group these so that we can see what it is that we actually have. And so here we now have we've made a rectangle out of this thing, and we can see that we do definitely we got 6 x's here. There's 4 and then there's 2. Okay, so those are like terms. So we definitely, we have grouped those. So we've got our like terms here. These are like terms here. Okay, and then everything else, nothing else has a like term to it. And so that's what we've done. We basically just grouped these. And so what we end up with is we've got x squared, we've got 6x, we've got 1xy, we've got 4y's, and then we've got 8. Now let's make sure we got all of those. We got x squared, we got our 6x's, we've got our xy, we have our 4y, and we have our 8. Okay, so that's what we've done is we've grouped these. Now all we have to do is figure out what is it that's actually making this. And so when we multiply these things together. And if we look at our base here, we look at our base, or we actually look, it might be easier if we even look towards the top of it. Okay, but in order to get y's all the way down, we have to have a y here. We have, this would be a y, here we have an x, and here we have 2. And then going up the side, what do we then have? Well, we got an x, and we've got 1, 2, 3, 4. And we got 4. And sometimes, depending upon where you are, it's sometimes easier to see it, depending upon what side you're on. So here we have our x plus 4. And then it might be easier if we actually were to put that up here. But nonetheless, so that's a y plus an x plus a 2. Y plus x plus 2, and then here we have our 4 plus our x plus the 4. So we could say, okay, so this is then x plus 4 times y plus x plus 2 is equal to x squared plus 6x plus xy plus 4y plus x. And so this is the product, which is the base times the height, and then this is our sum, which is what it equals, or rather addition only. So that's our product, and then we have our sum. Now what we have is we have a generic rectangle, and we're going to use that. We have a generic rectangle. We're going to use this generic rectangle to multiply 6x minus 1 times 3x plus 2. So what we have is we have our first factor here, and then we have our second factor, so we have 6x minus 1 we have 6x minus 1, and then we have our second factor, which is 3x plus 2. Which is 3x plus 2. And we're just simply going to multiply these together, and we're going to get our product. And so these two are being multiplied, and so this is going to equal what our product. It's going to equal the product, or rather it's going to equal the area, equals our area inside. And the area is what it talks about when it speaks of it as a sum. And then these two things combined, these are our factors. So this is basically simply the base times the height, which is our product. and when we multiply two things together, we get a product, and our product is written as a sum. So here's what we go. So we got 6 times 3, which is 18, x times x, which is x squared, and then we just simply multiply these areas. We have negative 1 times 3x, which is a negative 3x, and then we have 2 times 6x, which is 12x, and then we have 2 times negative 1, which is minus 2, and then we have our like terms. And so we've been doing this for a while, and we're fairly decent at it. So what we end up with is we have our two products. So our first one is 6x minus 1. And we multiplied that times the second factor, which is 3x plus 2. And then we got our area, which is inside, which is equal to 18x squared plus 9x minus 2. And that's what we got. And so we took our two, multiplied them together, and we got our area. Now what we're going to do is we're going to go this way. And that is what we mean by factoring. So we're not going to worry so much about going from the base times the height to get the area. We're now given the area, and we're going to find the base and the height. So we're going to be working these backwards. So the process of changing a sum to a product is called factoring. And so we have a couple questions here. Can every expression be factored? That is, does every sum have a product that can be represented with tiles? And we're going to look and figure that out. We're going to investigate this question by building rectangles with algebra tiles for some given expressions. And for each one, write the area as a sum and a product. In other words, we're going to write it like this. We have our factor number 1. So we have our factor times a factor and that's going to equal our area. And what we're going to be given is we're going to be given the area. So we're going to be taking our area, and we're going to be going, hey, what are the factors? So what are the base and the height? If we can't build it, let's try to prove that we can't build it. So let's get started. So the first expression that we have is 2x squared plus 7x plus 6. And we're going to take that apart and make a rectangle with it and see what tiles we can use to make this. And so we're going to try to make it into something that resembles the area model so that what's in here, what's inside, okay, somehow we're going to have to figure out that what's in here is going to be 2x squared plus 7x plus 6. And we're going to take that and make our factors out of it. So our first expression is 2x squared plus 7x plus 6. So we need to have 2x squared plus 7x plus 6. So we need 2x squares. We need 7 x's. So we have 1, 2, 3, 4, 5, 6, and 7. And then we need 6 ones. And what we need to do is we need to take these and simply somehow make a nice rectangle out of them. And it all just depends upon how it is that we're going to be making these and just trying to see, okay, what's actually going to fit with these. So let's see, it takes an x squared to make an x. So we can do it like this. And so we start noticing that somehow these things are going to fit together. And quite possibly we could do it like this. And so, and then we can make a rectangle out of this. So yes, this can be made into a rectangle. But now it's a little bit chaotic and kind of disorganized. So let's see if there isn't some way that we could take these and move these so we don't have, so we can put everything that's kind of the same sort of together, I guess would be the way to look at it. So we can put these together sort of this way. And just trying to make a nice sort of rectangle out of it. And that's still a little bit crazy. So let's try this. So we can somehow get a rectangle that looks a little more like our area model. And there, I think we have it. So let's take this, let's cut this out. Let's try that again. So there we have that, and that is our 2x squared plus 6x, 2x squared plus 7x plus 6. Okay, and now what we need to do is we need to figure this, and so let's put some lines in it to make an actual area model out of it. So as we can see, we do have definite sections, like terms, and that sort of thing. And so we now have to figure out what is it that's going around the outside of this. And what's going around the outside of this is we can pretty clearly see that one side we have 2 x's. So that is 2x long. This is 3 wide. So that's this one here. So this is 3. Okay, and then in order to get the x squared, we know we have to have, so this is one factor, and in order to get the x squared, we kind of just sort of start messing with our heads a little bit, and we know that this one over here that's 1x high, and then plus 2. So what we can do is we can take this, we can take these, and put these on the other side. And that looks a little bit more like, kind of like what we've been seeing. And if we take this and put this one on the bottom, so now we can say, okay, 2x times x is 2x squared, 2x times 2 is 4x. So here we have 2x squared, this is 4x. And then we've got 3 times x, which definitely gives us 3x, and then we got 3 times 2, which gives us our 6. And then if we were to combine like terms using what we've done before, we would go 4x plus 3x is 7x, and we definitely have the area. So that's just kind of how we sort of build these using algebra tiles. And so we would say that, well, okay. So we have x plus 2 times 2x plus 3 is equal to 2x squared plus 7x plus 6. And that's factoring. And so we were given the area, and we found the base and the height of that rectangle using the algebra tiles. And it takes some getting used to, but it is a bit of an experiment. So now we have 6x squared plus 7x plus 2 is the next one. So we need 6x squares. Seven x's. And then 2 1s. And we need to try to figure out a way to have this make a rectangle. Okay, so if we look at these, we can definitely do something like this. So let's see if we can make a rectangle first. And I think we're going to be able to. So yes, we can definitely make a rectangle. And so here we have our rectangle. And so now we just need to start organizing this a little bit so that we have something that kind of looks a little more like what we're used to. And so let's just see if we can't make this into a little bit of a slightly different shape. So now we have these here. And I think it's going to come together just fine. So now all we're doing is we're making sure, yes, we can make a rectangle out of it, and there we have it. And so we've got 3x, we got the 2 here, we got 3 x's here, and then we have 2 x's down this side over here, and 2 x's here, and then that's 1 high. So now all we have to do is figure out what is around the outside of this. So if you look at it, one side we know we've got 2 x's here and this is 1 high. So we have 2x plus 1. So that's 2 x's and that's plus 1. So that is one of our factors. And then across the top, we have 3 x's, and then we have plus 2. And it's kind of tough to sort of see that right now. But if we were to put up, which we are, and we put up some of these lines in here, we can see a little easier how we get the 3 x's, because we have 3 x's here. This is 6x squared. This is 4 x's over here on the bottom right, and then we have positive 2 there. And then if we were to combine our like terms, which these two are, we get our 7x, so we have 6x squared plus 7x plus 2. And so we would simply write this as 2x plus 1 times 3x plus 2 is equal to 6x squared plus 7x plus 2. So it definitely does take some practice getting used to it. But again, we keep at it. So here's the last two that we have. And so we need to come up with x squared plus 4x plus 1. So we need x squared, 4 x's, and a 1, and make that into a rectangle. So let's just get rid of some things here. And we need x squared plus 4x plus 1. So there's an x squared. Then we have 4 x's. X squared plus 4x plus 1. And can we make this into a rectangle? X squared plus 4x plus 1. And as we keep looking at it, we can try it this way. And now I've matched up all the x squareds around it. And we have, looks like we're going to need some more here. So let's try a different arrangement. And I'm not thinking we're going to be able to get a rectangle out of this one. So this one, you're free to give it a shot if you can. Let me know. But I'm going to say that when we put the x, even if we were to do it like this, we're missing 4. So not factorable at this time. So this one, we're saying we cannot make a rectangle with tiles. So the last one is 2xy plus 6x plus y squared plus 3y. 2xy. So we need 2 of these, 2xy's, 6 x's, a y squared, 3 y's. 6 x's, a y squared, and 3 y's. 6 x's, 6 x's, a y squared, and 3 y's. Two xy, 6x, y squared, 3 y's. 2xy, 6 x's, 3 y's, and a y squared. 2xy, 6 x's, a y squared, and 3 y's. Okay, let's see if we can make a rectangle out of this madness. So we have these. Let's just see if we can make a rectangle out of it. And we certainly can. So we can make a rectangle. Now let's try to make a rectangle in which we can create something that looks a lot more like something like this may actually work. So what I'm going to do, let's just try to do this. So that works. Let me just take these up here so that the ones and the things, the 1 parts and the x's and the y parts kind of match up a little better. And now we have ourselves a rectangle. And now all that's left is to figure out what makes this rectangle. So what can make this rectangle? Well, we know that a y is y units long. So this has to be a y, and this has to be a y for a y squared. And so you can kind of see that a little easier if we put that up here. And so then we have two x's here. That's two x's wide, so that one is taken care of. And then this is 1, 2, 3 high. And that might do it. So it looks like we have y plus 2x multiplied by y plus 3. And that should equal, let's see, if we put this in order that we have it, we have y squared, we got plus 2xy plus 3y plus 6x. And so here's our y times y. If we pull this down here, it's a little easier to see the y squared. So we have y times y, which is y squared, y times 3, which is 3y, 2x times y, which is 2xy, and 2x times 3, which is 6x. And to make this a little easier to kind of see, we'll put these in here. And there we have it. And there's our generic rectangle, and there's no like terms. So that is taking the area and rebuilding it using algebra tiles to figure out what's the base and the height, otherwise known as the factor. So we have factored these. So now we're going to work at these, and we're just kind of look at these triangles here, and we're going to see if there's any special strategies or ways that we can look at these to try to get the factors of these rectangles. And so one way to do that is to kind of go, okay, it always takes an x times an x to make an x squared. So we're always going to have an x times an x. So we got to have an x here, and we also have to have an x here because we got an x squared. And the only way that we're going to take the blue x to get that 2 is if we multiply it times 2. Okay, so now as we keep pulling these things apart, and it's all, everybody has their own individual strategies, but in order for me to get that 5, the only way 2 doesn't really go into a 5 very well at all. Okay, so it's probably not going to be a 2 right there, but this could be a 2 right here, and that could also be a 1. So 2x times 1 is 2x. So we have that. 2x times 1 is 2x. So that one is taken care of. And then we have 2x to get to the 6x squared. We're going to get 3. So 2x times 3x is 6x squared. So that one works. Okay, now in order to get a 5, we know that's going to be a 5 and a 1. We already have a 1, so now all we need is a 5. And that takes care of the 5. And 3x times 5 is 15x. So then we have that. So it's just kind of, it's a guess and check game, but there is some strategies. And so now to rewrite this, we would then look for like terms, and we go, okay. So this one could be written as 3x plus 1 times 2x plus 5 is equal to 6x squared plus 17x plus 5. I'm going to take this apart because I'm going to run out of room between these two. So there we are. So we were given our area already, and now we're finding the factors. So let's go ahead and hit up this next one here. Okay, so this one, if we look at it, we don't have any like terms in it, but we do have a 5 and a 15, and we also have a 6. So the only way you're going to get a 5, and we have the y's here, okay, and then we got x's going across here. So if we kind of look at this, we kind of go, hey, I've got this x here, and I've got this x here. So I need an x here. And I've also got this y here, and I have this y here, so I'm going to need a y here. Okay, so now I've conquered that part. And now I need to come up with a -2, a 6, and a 5. The only way I'm going to get 5 with 5x. I can't put a 5 here because 5 doesn't go to 2 very well, at least not with algebra tiles. But I can go, if I say, hey, I've got this 5 here, I can do that. And now I have 5x, y. And so then in order to get the 15, I need a 3. Because 3 times 5x is 15x. So I can put a 3 there. And now I've got to worry about the negative numbers. So I know I need a negative going across. And the only way I'm going to get that 2 is with a -2. And I think we're done. And so 3 times -2, so that would be a positive. Okay, so now we have 5x minus 2 times y plus 3. And that ends up equaling our area, which is 5xy plus 2y plus 15x minus 6. And there's no like terms with this. So this went. So he actually didn't go that direction at all. We went that direction. And that's the same thing on this side also. We went that direction. So we're factoring these things now. And it's a little bit different. And it's kind of a mind bender at times. So here we know this. Okay, so we've got 12x squared, 16x. So we've got x's here going across, which means I need an x here, and that's an x squared. So I will go with an x here. And that takes care of that x squared. And so now we're good with that. And then we have to get a 9, and we also have to get a 12. And so that 12, and we look at 12 and the 16. So if I focus on this 12 and the 16, okay, factors of 12. 12, we got a 3 times 4. And 16 is a 4 times 4. So I can put a 3, and I need a 4x somewhere. So I can put a 4 here. So let's just give this a shot and see if this is this one would be a 3. So now I got 12x squared. And 3 also goes into this 9. So if we take the 3 with the 9, we need to get a -9x, which means this has to be a -3. So now we have 4x minus 3. And getting back to the 16, that takes a 4. And that 16 is positive. So if we look there, and then 4 times -3 is -12. And I think we're done. So what we did was, and then we have our like terms, which are right here. So now we have, we've got 12x. We started with 12x squared. 16 minus 9, that's 7x minus 12. 16 minus 9 is 7. It's 12x squared plus 7 plus 12 minus 12. And we went this way. And so what that then gives us is we go, okay, so that's 4x minus 3 multiplied by 3x plus 4. And that's how we got that. So we started with our area, and we took it apart and found the base and the height. And that's factoring. So while working on rectangle problems, Casey happened to notice a pattern with the diagonals of each generic rectangle. Before she shared her pattern, she was called out of class, but she drew this on her diagram. And so what she shows is, she's showing 6x squared and 5. And then she's also showing 2x squared and the 15. And if we look at them, what is something that they have in common? And you go, I don't know. But if we multiply 6 times 5, this is 30x squared. And if we multiply 2 times 15, that's also 30, and x times x is x squared. Now, that's kind of interesting. If you multiply them, you multiply diagonally, you get the same product. Otherwise, or you get the same answer. Now, if we go back and check, does that really work? And so let's just see here. So what happens if we take 2 times 15 is 30, 6 times 5, that's 30. Okay. And then we have negative 2 times 15, negative 30. 5 times a negative 6, negative 30, x times y. Okay. 9 times 16, that's big. So let's just see what that comes out to. 9 times 16 is 144. Holy smokes. Look at that. And there's a negative there, so it's negative. And we got 12 times negative 12, which would be 12 times negative 12. Negative 144. Then we got 9, that's negative, times 16. That's negative 144, and we get x squared. So that's kind of interesting. So yeah, you get the same product. Far out. Kind of interesting there. Okay, so that's one way we can make sure that we have a good rectangle, I guess. Alright, so does it always work? So now we're just kind of looking at this, just kind of seeing, okay, what's actually happening here? So let's just see. So here we have, so we've got all of these. We're going to multiply diagonally and see if we get the same thing. And we just kind of went through that with the rectangles that we just did, because these are the same ones that are here. So, yeah. So the green, put the greens in here, so let's just kind of do this. And then we got our yellows here. And we'll see what the multiplication ends up being. So we already know that this is 6 times 5, so this is a 30 x squared. And this is also 30 x squared. And then here we have an x and a y in each of these. X times y is xy. 15 times negative 2, well, that's negative 30. And 5 times negative 6 is negative 30. Here we have 12 times negative 12, which would be negative 144 x squared. And then 9 times 16, well, we just did that. Let's do it again. We have 9, and that 9 is negative, times 16, and that's a negative 144. X times x squared. So yes, you do get the same products when you multiply across on the diagonals. So yeah, it appears so. So that's just a quick introduction into some factoring, and we're going to get a little deeper in the next couple lessons. So have a go at some of the problems, and see you online.